Assalamualaikum girls. I am Shamsunisa from Royal Degree College, Chemistry Department. As we are seeing Unit 2, Organic Chemistry, Chapter 2nd, Heterocyclic Compounds. Today we are going to study about preparation of FURAN, PYRROLE and THIOPHENE, Paul-Knorr synthesis. Structure, aromaticity, basicity and preparation of pyridine. So first of all, we'll see about the preparation of furan by Paul-Knorr synthesis. 1,4 dicarbonyl compounds on heating with phosphorus pentoxide, furan derivative is formed. Okay, you can see the reaction here. 1,4 dicarbonyl compound we are taking. This is the compound in which we are adding H plus. Means the reaction will take place in the presence of phosphorus pentoxide. Okay. Then what will happen here? In 1,4 dicarbonyl compound, here at this position girls. This position, carbon with 2 hydrogen atoms are there, and here also the carbon along with the 2 hydrogen atoms are there. So what will happen? One hydrogen we can represent outside the ring with the bond. Okay, single bond. Here one hydrogen with a single bond. Here one hydrogen at the single bond. So now what will happen? From this side, the 2 oxygen atoms are there now. From that one oxygen it is coming out. Okay, along with the bond. And this oxygen atom which is there, it is forming a bond. This particular bond, it is being attached in between the oxygen and this carbon. Like this we are getting the structure, like this. Then what will happen? As one bond we are representing outside the ring with the hydrogen, that hydrogen is coming out by leaving the bond, and that bond it is shifted inside the ring as a double bond we can represent. Then here also happening the same thing. Single bond hydrogen will be there, that H is coming out by leaving the bond there itself, and that bond is going inside the ring and forming a double bond here. So the 2 hydrogen atoms coming out reacting with one oxygen, and we are getting the side product water, and our main product is what? Furan derivative. Here alkyl groups are going to attach. Those alkyl group, methyl, ethyl, propyl, anyone. Same alkyl groups or the different alkyl groups can be attached, and it is named as furan derivative, what we are getting here. Next is preparation of pyrrole with the help of Paul-Knorr synthesis. 1,4 dicarbonyl compound on heating with ammonia, pyrrole derivative is formed. See here the reaction, 1,4 dicarbonyl compound. This dicarbonyl compound we are taking, in that we are adding ammonia, okay, and we are providing heat. Then what will happen here? Look at this very carefully. These 2 oxygen atoms are coming out. Okay, one oxygen, it is reacting with 2 hydrogen from ammonia, and we are getting 1 mole of water, H2O. Here remains what? NH, isn't it? Then this oxygen is also coming out. This oxygen is also coming out and reacting with the 2 hydrogen. From where those 2 hydrogens we are getting? See, from this side one hydrogen is coming out, and from this side one hydrogen is coming out. From this side one hydrogen is coming out by leaving the bond here itself, and that bond it is being transferred in between these 2 carbon atoms. Like this we can represent. From this side also, as the hydrogen is coming out by leaving the bond there itself, and that bond it is forming a double bond inside the ring. Here we are getting the double bond. Those 2 hydrogens reacting with one of the oxygen, and we are getting 1 more water molecule. Then in place of these 2 oxygen atoms, NH is remaining here in ammonia, isn't it? That NH is going to attach. So we are getting here 2,5 di-substituted, we can say, or the substituted pyrrole. See here, one alkyl group, it is attached at the 2nd position, and the another alkyl group is attached at the 5th position. So it is named as 2,5 substituted pyrrole. Okay. Next here, we are going to see about the preparation of THIOPHENE, which is named as Paul-Knorr synthesis. So 1,4 dicarbonyl compound on heating with phosphorus pentoxide thiophene derivative is formed. Thiophene derivative is formed. So how we will see the reaction here, as we are taking here 1,4 dicarbonyl compound. Okay, in that we are adding phosphorus pentasulfide. Phosphorus pentasulfide we are taking. So what will happen first of all, from this side, see double bond O is there now, oxygen is coming out, in place of that one sulfur is being attached in place of oxygen. So we are getting this particular compound. Then in this, what will happen, we are adding H plus. Okay, we are adding H plus. That H plus, it is going to attach with the oxygen, with the bond. From where the bond is getting, that is on oxygen, we all know that lone pair of electrons will be there. Sharing and pairing of lone pair of electrons will take place, and it is forming a bond with the H plus, and we are getting the single bond H. Okay, rest of the things are as it is. Now what will happen, as we are seeing the third structure, in this what is happening, this as lone pair of electrons sharing and pairing and forming a bond with the hydrogen, so oxygen is becoming electron deficient, so the positive charge will be there on the oxygen. To satisfy that position, one of the bond from this side, it is being transferred on the oxygen and again forming a lone pair of electron on the oxygen. Okay, then at the same time, double bond sulfur, carbon double bond sulfur is there. One of the bond, it is going to shift here, this side, means it is forming a bond here with the sulfur. So we are getting like this. Look at the fourth structure, single bond S. Okay, and here single bond S remains. Then here this side, one hydrogen we are representing outside the ring. Okay, then what will happen, this hydrogen in the next step, it is happening like this. This hydrogen, it is coming out by leaving the bond, and that bond, it is shifted here in between these two carbon atoms as a double bond. This fourth structure we are getting. Okay, the fourth structure we are getting, and from the fourth structure what will happen, see, think that one hydrogen is present here, which we can represent outside the ring. Okay, like this we are representing in the next structure. The rest of the things are as it is. So now what will happen, this hydrogen, it is coming out by leaving the bond here itself, and that bond, it is being transferred inside the ring and forming a double bond. And at the same time, OH is attached with the carbon. Now that OH is coming out along with the bond as OH minus, OH minus H plus. So we are getting the side product as water molecule, and our main product what we are getting, that is thiophene derivative. Next, we are going to see about the structure of pyridine. It is a 6-membered heterocyclic compound. Nitrogen present as heteroatom here. You can see the structure. Carbon atoms, how many carbon atoms are present in the ring? 5 carbon atoms and 1 heteroatom, that is nitrogen. So it is a 6-membered heterocyclic ring compound, we can say, and on nitrogen lone pair of electrons present. Now, aromaticity of pyridine. Pyridine has 3 conjugated double bonds. It possesses 6 pi electrons. It obeys Heckel rule. Like benzene, pyridine also has 2 equal structures and 3 more other structures. Look at the structures, girls. We can see that resonating structure of pyridine here. This is the first structure of the pyridine. Okay, now what is happening, as alternate double and single bond is present, this double bond, it is transferred towards that side and forming a double bond here, and this bond, it is shifted towards this side, double bond, and this bond, it is shifted towards this side here, forming the double bond. Okay, then from this what will happen, one of the bond from this side is being shifted on the nitrogen, and we are getting a lone pair of electrons on the nitrogen. Excess of electron will be there on the nitrogen, so it will carry the negative charge. And as this bond is shifted towards this side, this position is electron deficient, isn't it? So we are representing with the positive charge. Next, from this we are getting the another resonating structure. How? See here. To satisfy this position, from this side, one of the bond is shifted towards this side. So here we are getting the double bond. So this position is becoming electron deficient here. This position is becoming electron deficient, so we are representing a positive charge here. Then rest of the things are as it is. To satisfy this position, we are shifting this particular bond, one of the bond, it is shifted towards this side. So the positive charge will be created at this carbon, isn't it? Then this is structure here we are getting. So after this, look at this again with very carefully look at this structure. As we are having already, we have seen this particular structures, isn't it? The negative charge will be created on the nitrogen. So in the resonance structure of pyridine, negative charge is present on nitrogen. Here you can see negative charge is present on the nitrogen and positive charge is present on the 3 carbon. On the 3 carbon atoms, the positive charge is present. See first of all here on this carbon, positive charge, and next carbon, and here also third carbon. Then here electron density on ring carbons in pyridine is less than that on benzene. Now we will see the basicity of pyridine. Pyridine is weak base. It reacts with HCl and forms pyridine hydrochloride salt. See the reaction here. As we are taking the pyridine, in that we are adding hydrochloric acid. Pyridine is a base. It is made to react with the acid, that is hydrochloric acid, on reversible equation. What will happen here? In between hydrogen and chlorine bond is there. Now, one of the bond it is shifted towards the chlorine. So the chlorine will carry the negative charge and hydrogen will become electropositivity. It will show it will carry the positive charge because of electron deficiency. Okay. Then what will happen? That positively charged hydrogen, it is being attached with the nitrogen of pyridine. As on nitrogen, lone pair of electron is there, sharing and pairing of electron will take place and it is forming a bond with the hydrogen. So we are getting like this. On nitrogen, electron deficiency will be there, so it will be carrying a positive charge, and we are getting the side product what conjugated base, that is nothing but the chloride ion. So this conjugated acid, it is named as pyridinium or pyridine hydrochloride salt, we can say. The lone pair of electron on nitrogen atom, as we have already seen in the pyridine, that is responsible for the basic character of pyridine. Now we will see about the preparation of pyridine, how to prepare the pyridine. Pentamethylene diamine hydrochloride on heating with concentrated sulfuric acid at 300 degrees centigrade forms pyridine. Okay, how we will see here. Now you can see the reaction, girls, as we are taking pentamethylene diamine hydrochloride. This is the structure of pentamethylene diamine hydrochloride, and we are providing the heat to it. How much temperature we are maintaining here? 300 degrees centigrade. So what will happen here? After providing the temperature 300 degrees centigrade, from this side, girls, look at this very carefully. NH2 HCl, this whole group it is coming out. Okay, this whole group is coming out, and from this side NH2 is there na. So from this side one hydrogen is coming out. So how many hydrogens now? NH2 here, one H3, and from this side one hydrogen is coming out, so NH4, this Cl. So we are getting the side product as NH4Cl, and here remains what? NH. Okay, it is forming a center position over here, and it is forming a bond. This nitrogen, it is forming a bond with this carbon and this carbon also. Okay, here a ring formation will take place. On nitrogen, you can represent a lone pair of electron. It is named as what, girls? Pyridine. So we are taking the pyridine, and in that we are adding concentrated sulfuric acid, and we are providing heat, and we are maintaining here the temperature 300 degrees centigrade. Then what will happen here? In understanding, girls, each corner on each corner carbon and 2 hydrogen atoms are present. Okay, 2 hydrogen atoms are present. So from this side, one hydrogen atoms are coming out, girls. 1, 2, 3, 4, 5. Okay, these 5 hydrogen atoms are coming out from this side, and in place of that one, here bonds are going to form, alternate double bonds are going to form. Here one double bond, and this side the one double bond, here one double bond is going to form, and from this side also this hydrogen is coming out, okay, along with the bond. So altogether 6 hydrogen atoms are coming out, we are representing that one 3 hydrogen gas. Means altogether how many hydrogens? 3 to the 6. Those are coming out, and what the structure we are getting after the elimination of hydrogen, that is known as pyridine. Thank you for listening my lecture.